Hello, everyone, and thanks for joining me on this new topic. So, this is going to be a relatively shorter one because probability, at least at a year seven level, which I'm going to be teaching here, isn't too extensive. And once we kind of build up your intuitive understanding of this topic, the rest and actually trying questions shouldn't be in theory too bad. But I'm going to introduce you to a couple of concepts, like I do with every introductory video to a course, and we'll go into some examples a little bit later. So, what is probability? Well, probability, as you may have heard, is the study of chance. It is the study of a likelihood that something will happen. Now, the most common kind of starting point for probability is people talk about a coin flip. So we've got this coin here that I've drawn badly, but we have this coin and we flip that. Now, we're talking about probability as the likelihood of different events occurring. So the way we can think about this is, well, how many different possibilities can I have here of this coin flip happening? Well, one would be that it would be a head, and the other that it would be a tail. So there are two possible events occurring here if we look at strictly a coin flip. So we're gonna flip this coin, and one of the two outcomes will happen. We will either get a head or a tail. Now, each of these can be represented as some likelihood of it happening. And typically, we will use this as either a fraction, a decimal, or a percentage chance of something happening. Now, looking at a head and we'll start with fractions, and I'll get you in a minute to think about why we may use fractions, but we think of any probability as a fraction of, well, every possible event. In this case, it was 2. So we have every possible event. And over that, we have one specific event. So that would be, in this context, a head or a tail. Now, let's think of why. Before we even go into the probability of a coin flip, let's think of why we could represent this as a fraction. Now, the way I think of probabilities and the way it, for me, makes sense intuitively to use fractions is that every event occurring is a fraction of a whole set of events. So we look at fractions as being some portion of a whole. Well, in the same way, each probability, each specific event happening, is some portion or fraction of an entire array of different events, right? When we flip a coin, a heads or tails is a fraction of two different likelihoods of this being heads or tails. Same with a dice roll, for example. The probability of you rolling a 2 is a fraction of you rolling any number of numbers ranging from 1 to 6. So this is why, for me at least, a fraction makes sense. Now, in the context of a coin flip, we have, well, how many different events do we have? We have a heads or a tails. So actually, I'll draw it next to here. So say I got a head. Well, getting ahead is one likely event, is one of the events. over, all possible events that could happen. So we get a half. Now, for tails, this is also one event out of a possible two events. So once again, we get a half. So the probability of each of these happening is 1/2 or 50% or 0.5 if you wanted to do it as a decimal. Now, the same thing goes for something like a dice roll. And these are kind of the two starting points of probability because they're the easiest to sort of visualize. Now, if I were to draw my die, my six-sided die, and we have one here, we have two, we have three, and we have all the other possible outcomes on my other faces of my die. So in this case, well, we have 6 different events. So the probability of each of these happening, of rolling a 1 or a 2 or a 3 or a 5, these are one event out of a possible 6. So we can say that each of these events, each of these events being the number that we roll, as being a fraction of every possible number we can roll. Hence, we'd get a probability of 1/6 for each of these events. So I'll actually write here each event. This being the number rolled. Now, what if I were to ask you, for example, well, we've looked at, obviously, just each individual number, but what if I were to say, well, what's the probability, what's the likelihood of rolling an even number? Well, how many different even numbers do we have on our die? And I'm actually going to write this down here and to show you some of the notation we use when we write probabilities. So we write P for a probability, and in brackets, we just write the event in question. So P, probability of rolling an odd number. Well, we still have 6 possible events that will happen. So that's all good. We can still write this out of this fraction as something out of a possible 6 events. But we have more than one event that can happen here, right? Because odd numbers, at least in the context of this die, we have a 1, we have a 3, and we also have a 5. So there are 3 different events that can happen. And the probability of an odd encompasses all 3 of those events, which we have here. So there's 3 events that can happen when we look at rolling an odd number out of a possible 6, because there's still 3 events that aren't this favorable event that we're looking at. We could roll an even. So that makes up another 3 possible events. So this is the idea of probability at this level that we're going to talk about. It is the study of making sense of the world around us and the chance of certain things happening. And with the fractions that we get, and that's why I'm going to write these things as fractions, although we can use decimals and percentages, but fractions to me make sense because each of these events, for example, rolling an odd number, is going to be a fraction of all possible events that we can roll. And just to quickly finish up, we have 3/6 here. And using what we know from equivalent fractions and simplifying fractions, you can refer to my video on this if you'd like, a little bit of a refresher. We can say that this can be simplified to 1/2 because it makes sense. Well, we have three numbers that are odd, three numbers that are even, and out of 6, each of these would make up a probability of half. So the probability of rolling an even number is 2, 4, and 6. That still makes up 3 out of a possible 6 events, which also gives a probability of a half or 50% when we express it in percentages or something else. So that was just a light introduction into probability, and we will move on to a couple of other concepts throughout this series. But like I said before, it'll be quite a short series because if you can get your head around this idea of probabilities as being, or each event in a probability being a fraction of all of the possible events, working through certain questions becomes relatively straightforward if you just consider, well, how many total events can I have with this type of formula we've had? Well, how many total events can I have? And what specific event am I looking at? So I'll see you in the next video.